right, we are now recording. Let's go from current slide, and this is messed up again. Okay. All right. Not the slide. Okay, that's a good place to start. Okay. Let me first tell you a few announcements. And there is Lauren, right? Has anyone else come in since I called roll? While I was fiddling with the computer. All right, just a few announcements. First of which, I guess, would be that Friday, tomorrow, at 10 o'clock in the morning, I've seen these posters all over the walls and doors and stuff. I think it's the UAB Theater Company or department is presenting a Shakespearean comedy, Taming of the Shrew, one of probably his most well-known and famous of his comedies. And they're presenting this on the Birmingham East Campus in the A.G. Gaston building. It's the auditorium there in the A.G. Gaston building. The original Taming of the Shrew, Shakespeare's version, the woman was a very strong-willed, independently minded woman, and at a time that wasn't usually the case, and the guy was trying to tame her, okay? And it was really funny, I'm sure, in Shakespeare's time, and Shakespeare's pretty good. Well, either the company there at UAB or someone has come up with a twist on it, and they have the man being the very strong-willed, independently minded person that's very inflexible, and the woman trying to tame him. So he's the shrew in this one. They say it's still supposed to be quite funny, and so if you want to go, it's a free admission. We don't have many opportunities like this to see Shakespeare on Lawson campus. So it's on the Birmingham East Campus in the in the A.G. Gaston Auditorium. Trey, right? 10 o'clock in the morning. 10 o'clock in the morning tomorrow morning. Should be quite good. Okay. Usually office hours today are 1:15 to 3:15, and I think they still will be, but I've got a car that's not running down at Pet Boys, and I've got a rental car out here. That's why I was late this morning. The rental car place did not open until 7:30, and then they didn't have their computers up. It was I was late, but not as late as I was afraid I would be getting here. So anyway, I'm going to have to be fiddling with that kind of stuff, but I think I'll be on campus the whole time doing it. I hope I don't have to run off campus, but if in case I'm not in the office, that may be where I am. Okay, tomorrow my office hours are 7:45 to 11:45, though I may be going to the thing at A.G. Gaston building, especially if they need people to be there. They expect us to be there to fill seats. Okay, so I'd like you to be there to fill the seats. So I have grading to do. I don't have to, but it should be a great comedy. But anyway, then we also may be having a meeting in the afternoon. The last I heard, it hasn't been announced yet, so I don't know if we're meeting or not, but that will be outside my office hours. Okay. And that may actually extend my office hours if they meet at 12:30 or 1 or something like that. So, any questions on anything we've done so far? All right. Now, I wanted to check one thing. I can't recall if I got my quizzes back. There's the test. Yeah, I got them back. And they got it. All right. Because when we finish the section today, I'll be giving you the quiz on chapter 2. Which means, let me go on and get this said too while we're saying it. This class is probably not one of the, it's a great class, but not one of the best at getting research papers in. Out of started with 31 students, I think now we're down to 28, and 4. That's 1/7 of the class have turned in research papers. We're in the second half of the term, folks, so please don't forget to do that. Now, the first quiz, I still have 1, 2, 3, 4 people who haven't turned in the first quiz, which means at least those 4 people haven't done the first test. Actually, 1, 2, 3, 4, 5, 6, 7 people either haven't, I can't tell if you finished the test or if you've even started taking it yet. So please, folks, we're already ready time for the second quiz. You need to not get too far behind. Now, I'm probably preaching to the choir because most of you, I think, are up to date. It's probably mostly the people who aren't here that are not. A few of you still need stuff, okay? Now, okay, I guess that's all I need to say there. I'm glad I got it on Screencast-O-Matic, so in case anyone is listening, they will know. Please get caught up, because it's hard to get caught up if you get more than a test behind. That's really tough to do. So please move on that. Now, a couple of those I was talking about, if I haven't seen in a long time, they may not be coming back, but so far they haven't withdrawn. All right, last time we were, gotta get the pen set up, talking about long division of polynomials. And I thought we did example 2. Did we just set it up, but did we not finish it? Huh? But what? We ran out of time. Okay, so let's do example 2. This is on the top of page 138, chapter 2, polynomials and rational functions. We're still on the polynomial part, 2.3, polynomial and synthetic division. So we want to divide x cubed minus 1 by x minus 1. What would I put where? I'll draw the little house for you. You tell me what to put where. I think we did this last time. X minus 1 on the outside. Okay. X cubed plus 0 x squared. You can put a minus 0 x squared, plus or minus 0, it doesn't matter. But you got to have an x squared term. Plus what? 0x. You got to have an x term. Doesn't matter where you put plus or minus. And then minus 1. Got it. You have to account for every power. 3, 2, 1, 0, left off. Okay? Now what? Now what? Yes, and how many is that? X squared times. Now, y'all may find this hard to believe, but my Calculus 2 class that met yesterday morning is doing what we call integrating by partial fractions. And one of the first steps with that is if you have an improper fraction that you're trying to integrate, you divide. Long division. Y'all are better at long division than they are. I was having to pull teeth to get them to remember how to do long division. So it isn't something that's going away after the next quiz or test. Okay, this will be with you for a while. Okay, so I asked almost that same question, how many times will x go into x cubed or something like that? I was told 2. No, x squared. Okay, go ahead. What do you do next? Yeah, multiply, and that gives you x cubed minus x squared. Very good. Okay? You can put the 1 if you want to. It's not required. Okay, what do we do next? Okay, yeah, change signs and stuff like that. Okay, yeah, we change signs and add. Okay? You can do subtraction if you remember the rules for doing, but it's so much easier to change signs and add. So let's make that a minus, that a plus, and add. Of course, what happens here? The x cubes, they go away. They add the 0. That's exactly what we want them to. And the x squared, what do we have? X squared. And what do we do next? Bring down a 0x. That's not much to bring down, is it? Okay? But we'll do it. And then what? Okay, x will go into x squared how many times? X times. Very good. Then what? Multiply. X times x is x squared. X times a minus 1 is minus x. What do we do next? Change signs and add. Okay? What does that give us? 0 there. X here. Bring down the minus 1. Then what? It'll go exactly 1 time. And that 1 times x is minus 1 is x minus 1. No remainder. That meant it factored exactly. Went into it an exact number of times. Okay? Long division, when you have missing terms, polynomials. Okay? Now, there are 2 ways we could have done this problem without long division. Okay? One we're going to learn next, and that's synthetic division. And if you want to, we'll come back and do it with synthetic division. But the other, remember what division is? You can write it several ways. They've been writing it horizontally. I like to do a lot of things horizontally, but sometimes you can do things vertically, and you could write this as x cubed minus 1 over x minus 1. That also means division, doesn't it? That line is a dividing line. Horizontal line is a dividing line. If you were given the problem in that form, what might you choose to do? Think back, chapter 3. What's the F word? Oh, factor. Let's see. Is x cubed minus 1 factorable? It's a difference of 2 perfect cubes. That sounds familiar, doesn't it? Okay. How would it factor? Anyone know? X minus 1 times x squared okay, remember the rule? All right, I made it up. It wasn't really a rule. Okay, you take the cube root of this, x, same sign here, cube root of that, 1. So that's x minus 1. Then forget about this part and just focus here. Square this, x squared, opposite the product of these 2, plus x. Yeah, plus x. I thought that's what you meant. Okay, plus x, and then square the last term, which is plus 1. Okay, divided by x minus 1, and guess what happens? They go away with sound effect. Okay, and what do we have as the answer? X squared plus x plus 1, x squared plus x plus 1. So you didn't have to do long division in this if you remembered, hey, wait, I can factor that. Get rid of x minus 1, and sure enough, we have an answer. Okay? Now, when we do synthetic division, we'll have yet another way to do it. We're going to get there after one more example. Any questions on this one before I delete? Okay? So, let's erase all that ink and do example 3. Now, before we do this, now remember, every example in the book has a checkpoint, okay? And those checkpoints, go to them, try to do them as soon as you can after class while it's still sort of fresh on your brain. And if you get stuck, you can always go to larsonprecalculus.com for an audio-video solution for those checkpoints. Okay, but before you even start example 3, notice what's written there. See larsonprecalculus.com for an interactive version of this type of example. So not only are they going to do it for the checkpoint, they're going to do an interactive version there. So when you do the checkpoint here, if you find out you're having problems, go and check them out there. So let's see if I can get my pen loosened here. It's tangled up. Divide negative 5x squared minus 2 plus 3x plus 2x to the 4th plus 4x cubed by 2x minus 3 plus x squared. Okay, it's a division problem, so I'll go on and draw my house here. A very pretty house, but it's a house. What do I put where? All right, notice what she did. And you better do. When you write this down, write it in descending order of the powers. So first do x squared plus 2x minus 3. That's exactly what you've got to do. X squared plus 2x minus 3. And 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. All right. I hope I wrote the problem down right. Seem okay? Now what? 2x squared times. Very good. If you have a little problem seeing that right off the bat, do the numbers first. 1 will go into 2 times. And then x squared will go into x fourth, x squared times. X squared times x squared is x fourth. Okay. Good deal. Now what? Okay, 2x squared times x squared is 2x to the 4th. Good, that's what we wanted it to be. 2x squared times 2x is what? 4x cubed. Okay, good. Negative 6x squared. Very good. Now what? Change signs and add. So that becomes a minus, that becomes a plus, and the other one becomes a minus. Okay? That goes away, and lo and behold, that one goes away too. Huh. Okay? What's left? An x squared. Okay? Now, since we got rid of 2, then let's drop down 2. So what do we bring down? Plus 3x minus 2. Because we need 3 terms to deal with this. And then what? Oh, and here's, wait, time out. When you have your remainder here, like we do here, you always look up here and check. If this degree is less than that one, you're through. Is this degree less than that one? No, it's the same. So you're not through. Let's continue. What do you get? X squared will go into x squared how many times? Plus 1 time. Okay? Then multiply. Say again. X squared plus 2x minus 3. And then what? Change signs and add. That becomes minus, that becomes plus, and the middle one goes to minus. Okay? And that goes, whoops. Oh! My eraser didn't quit erasing. Okay? That was an x. Ugh. That was an x squared. This was an x squared. Okay. These add to 0. What do those add to? X. Second? Plus 1. Exactly. Now that is a remainder, and you can either write it as a remainder or you can write it as a rational expression, which is the remainder, x plus 1, over the dividend, x squared plus 2x minus 3. Let's see how the book wrote it both ways, okay? 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. And then they said you could, well, actually they wrote it that way and left it. You can check the results by multiply, just like you used to do in grade school. Multiply the divisor times the quotient. That looks like a lot of fun. And then when you get through with that, add the remainder to it. You should wind up with the dividend. I think I'll leave that to the student, okay? It'll take a little bit of time and effort, and since I got started late because of my car situation, we'll go on. So, any questions on long division of polynomials? Okay, I'm going to give you a few hints now. We're moving to synthetic division. This problem here would never be done with synthetic division, okay? Synthetic division requires a special condition for your divisor. This one fails it miserably, okay? You will not be able to do this problem with synthetic division. You're going to have to use long division. So let's move to synthetic division, which is going to be a few slides away because I couldn't find a slide with white on it, enough white on it to do those exercises. So here we are at synthetic division, okay? That's sort of like a virtual friend, right? Never mind. Okay. There is a nice shortcut for some long division of polynomials when you have a divisor of the form x minus k. Now, here's how I like to refer to that divisor. The divisor, the x term, has a coefficient of 1 and exponent of 1. If it doesn't, you can't use synthetic division. If you want to remember x minus k, that's fine. But I like to just look and say, is the coefficient of that linear term 1 and is the leading term of the divisor coefficient 1, exponent 1. If it is, you can use it. If it's not, don't even try. The pattern for the synthetic division of the cubic polynomial is summarized as follows. The pattern for higher degree polynomials just continues. So let's say we had ax cubed plus bx squared plus cx plus d. Don't you love it when they use letters rather than numbers? It's just so much fun, okay? Divided by your good old x minus k. Now remember, that doesn't have to be a minus. That's why I like my version better, to be x plus k. It just depends on what you put out front there, okay? The thing is, you can do it if your coefficient is 1 and your exponent is 1 of your x, okay? So here's the pattern. Whatever in your, okay, I'm going to back off again. Let's go back here and let you remind me what we did here. Okay? Or this is a different problem. Okay, what do? We divided. Now this one, could we have used synthetic division? Yes, okay? Coefficient 1, exponent 1. We could have done it. But what was the thing we did? We went this into this, multiplied that, and then we did what? Change signs here. Okay. Now notice about the x's. That leading thing, this went away, that went away, that went away. So we really never used the term with x's in them. They always added to 0, right? So the only term that really carried the day for us was this term, okay? But what did we do? We changed signs, we changed signs, we changed signs. So why not just change that sign? And that's exactly what we do. So when you have an x minus k, we just write the opposite of whatever that k is. Whoa, I went too far, didn't I? Where is it? Oh, no, I didn't. Okay. Here we go. So, rather than writing x minus k here, just put plus k here. Now we don't have to change signs, okay? just put the plus k here because the x's always disappear, especially if you have a coefficient of 1. Okay? Now, what you also do for the dividend here, you just write down the coefficients. Remembering that if you skip a term, you have to put a 0 instead of that coefficient. So you put an A here, a B there, a C there, and a D there. We have no x's anywhere, okay? K here, the opposite of this one, and your coefficients there. Then what I say to do, I don't block it the same way they do. I usually block it like this. And I say skip a line and draw a line. Okay, the book never says that. Dumb statement. Skip a line, draw a line. Bring down the A. Because think back. Sorry to keep doing this to you. But notice here, it's not the same one we were looking at before. The 1 here always applies that. That's why I like writing it above it, not skipping over it. As long as this coefficient is 1, whatever this coefficient is going to be up there. So you see the A is going to come down. Okay? So let's go back. All right. So you bring down the A. Just drop the A down here after you skip the line, draw a line. Now what you do is multiply. We used to multiply on top. We brought it down here. So K times A is KA. Okay? Well, that's just a number, so don't keep up. And then, because we already changed the sign, we just add. Add these two numbers together. Then you multiply these two and add. You put the result here, add coming this way. Multiply here, write it there, add coming this way. When you reach that last one, block that off, that's your remainder. Always. So, what do you have now? Because you had an x here, and that first time you divided into the variable, now we put the x's back in, the variables back in, but drop a power, right? Because x goes in the x cubed, x squared times. So this becomes ax squared plus blah, 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 x plus a number with the remainder of that. Every time. Every time. Because how do you know your remainder can't have an x in it? That it's always going to be a number. Remainder has to be lower degree than your divisor. What's the degree of the divisor? 1. So this has to be a degree 0. Okay? And therefore that always is going to be a number. So what they say, vertical patterns, you add the terms in the column. Diagonal patterns, you're multiplying your k times the thing at the bottom. Okay? And then you write down your thing. This is going to be the coefficients of the quotient. So the variables you put back in, just like you took out the x's, you put them back in, always start one less degrees of that, because you divided by x. Okay? So it'll be ax squared plus something else plus a constant with a remainder of another constant. Okay? So this algorithm for synthetic division works only for divisors. How many times have they said this now? Of this form, x minus k, how I like to say it, coefficient 1, exponent 1. If you have that, you can use synthetic division. But remember, it doesn't have to be a minus there. If that's a plus k, that's the same as x minus a minus k. So then you just put the negative k out front. Okay, so whatever the k sign is here, just change it and put it out front there. It's always the opposite sign. Because we change signs to add, right? Okay. So let's do example 4. Here's your problem. Divide x fourth minus 10x squared minus 2x plus 4 by x plus 3. Which way you want to do it? Can you even do it synthetic? Yes, because the coefficient is 1, the exponent is 1. So what do you put outside the box? Negative 3. You got it. What do we put on the other side of the box? No, we don't put any x's, do we? 1. Say again? Second? Yeah, a 0. Absolutely. Next. Negative 10. Keep the sign with them. Negative 2. 4. Okay? Yeah, you don't have to put pluses if you want. You can if you want to. Now, here's my little check. Okay? I like to do little checks every now and then. Okay? Little slip box or fine. So, what is your degree here? 4. How many numbers did you better have here? One more. 5, because you have to have 4, 3, 2, 1, 0. So you have 5 times that. You're always going to have one number more here than what your maximum degree is there. Always. If you don't, you've left out a term. Okay? So that's a little check. Now, what's the next rule for me? Skip a line, draw a line. Good deal. Now what? Bring down the 1. Then is negative 3. Then you do what? Add. And what you get? Negative 3. Then you is positive 9. Very good. Then you add, and that gives you negative 1. Then you multiply, and you get 3. Then you add, and you get 1. Then you multiply, and you get negative 3. And then you add, and you get 1. Block that one off. I do. The book doesn't, but I do. Okay? That makes it sort of symmetric, doesn't it? I drive my wife crazy trying to get everything symmetric, but she likes things asymmetric. Okay? Okay. What is your answer then?
X3 minus
X to what?
X3
X cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. You got it. There is your solution. Okay? Here's your quotient. There's your remainder. You just put in the x's 1 degree less than what your dividend was. Fill them in. Set it down. Make sense? Let's see how they do it. Now, if you know it some other way and you're more comfortable with it, and you say, oh, his way is so complicated, and you like to do it another way, as long as it's right, do it, okay? I'm not this stickler that you have to do it my way, unless you have to do it my way. No, okay, no. I'm married. I'm not used to having things done my way, so you do it any way you want to. Okay, so what do we do from here? Okay. You write down the numbers. Make sure it does work. It does because coefficient 1, exponent 1. And then put the opposite number from your 3 there, put a minus 3 here. Put your coefficients here, allowing for 1 for every term. If you're missing a term, put a 0 coefficient for it. 1, 0, negative 10, negative 2, 4. Be sure you keep the signs with them. Okay? Then, skip a line, draw a line, bring down the 1. Okay? Do we need to do it again, or you want to just watch them do it? Okay? So, they're going to bring down the 1. They haven't done it yet, so there they did. They brought down the 1. Then they multiply negative 3 times 1 is negative 3. Add 0 plus negative 3 is negative 3. Multiply negative 3 times negative 3 is 9. Add negative 10 plus 9 is negative 1. Multiply negative 3 times negative 1 is positive 3. Add negative 2 plus 3 is 1. And then multiply negative 3 times 1 is negative 3. Add the final time, 4 minus 3 is 1. These are the coefficients of your quotient. That is the remainder. That's why I like to sort of separate it so you don't confuse it there. And then plug back in your x's just like you took them off here, plug them back in here. Always drop the degree by 1. X cubed minus 3x squared plus minus 3x minus x, I can't call it, plus 1 with a remainder of 1. Make sense? Not that hard, in fact. And which you like better? Long division's fun, isn't it? No, this is a lot easier, isn't it? Okay. So that's example 4. So then you can write down your solution. You can do it several ways. One way is this. The divisor divided by, the dividend divided by the divisor is your quotient here, right here, your quotient plus your remainder over the divisor. That's one way to write it, or you can write the quotient with remainder 1 if you want to do it that way. All right, any questions? Okay. That's the only example we have of synthetic division. There is a checkpoint. Please take a look at that. Make sure that you can do your synthetic division. Now, did you want to go back and do one of those others we did, long division, just see if it got the same answer? Or are you confident we will? Okay. If you want to, I'll go back and do it. Glad to. Okay? That one, the last one we did, x cubed minus 1. Did you want to see that one? You're okay without it? Huh?
If it was divided by x minus 3, would we put a
Plus 3 in front. Yeah, exactly. It's always the opposite of that. That takes the place of changing sign. Here's the other thing it does, folks. Okay? Remember, this is the divisor with x plus 3. Now, later on, okay, in fact, the very next thing we do, if that remainder happened to be a 0, what did that tell you?
It was perfect.
It goes into an exact number of times, and those are factors, exactly. So that becomes a factor. And if that's a factor, what's a solution? X equal negative 3. So actually, it's your solutions that you're putting right out here. Just like if this is a factor, your solution or 0 for that polynomial would have been x equal negative 3. So that's what you're putting out here. So think of it either way you want to. The opposite sign from that one or what your solution would be. Because that is actually what we're going to do next with first the remainder theorem and then the factor theorem. And my goodness, we're going to find some surprising, maybe not too surprising, but some interesting results. All right. The remainder obtained in the synthetic division process has an important interpretation. Okay? And this is the remainder theorem. If a polynomial f of x is divided by a binomial in the form of x minus k, coefficient 1, exponent 1, then the remainder is, surprise, surprise, if you plug in this k to that polynomial instead of x, you'll get the remainder as an answer. Oh man, can we believe that? Let's go back and see if that's true. Okay? Let's go back to the one we just did. Oh, wait. Okay? We'll have to use their answer. Oh, here we go. Yeah, we can use it right here. What was our remainder there? 1, right? Okay? Okay, let's see. No, okay, I'm sorry. Our k here was negative 3, right? So let's take negative 3 and plug it into our original problem, x to the 4th minus 10 x squared minus 2x plus 4. What we're going to plug in is x equal negative 3. We're going to plug that number right there into that. So what does this give us? Negative 3 to the 4th power, you tell me. Continue. Minus, plug it in. 10, negative 3, squared, minus 2 times negative 3 plus 4. Okay? Now, anyone know what negative 3 to the 4th power is? Yes, you do. What's negative 3 squared? 9. And what's 9 squared? Isn't it 81? You square it, it's squared. Second, fourth. So yeah, so this is 81, and it's a positive 81 because that was an even exponent. Next. Okay, no, you square first. Negative 3 squared is 9. Negative 10 times 9 is negative 90. Very good. Plus 6 plus 4. Okay? Can we add those together? Well, this is positive 81. 6 and 4 is 10. That's 91. Minus 90 is ding, 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 ding. 1. Now, that was not particularly easy to plug in. That was pretty easy to do synthetic division. So if you're ever trying to find what a value is, say x equals, make up any other, 5. Rather than raising 5 to the 4th power and squaring it and multiplying and stuff like this, just do a 5 out here. And you'll get your answer for the remainder every time. And that's easier math. This is just simple multiplications and addition. That's raising the power, especially the bigger the numbers, the nastier it gets. So it's really much easier to do it that way. Ha! A new way to evaluate a polynomial at a given value. Okay? So let's go back to this, and that's what it said, and we just showed it working. Okay? The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. That is, to evaluate a polynomial x when x equals k, just divide alpha of x by x minus k. In other words, put k on the outside, and then do your polynomial coefficients there, and then go to town with sound effects. Okay. Now, let's do example 5. Use the remainder theorem to evaluate alpha of x equals 3x cubed plus 8x squared plus 5x minus 7 when x equals negative 2. So what would you put where? Say again? When it's equal to, you put the number down. If it's written in factored form, like if you added 2 to both sides, that would be x plus 2, right? Then you would change sign. So if you write it in equal sign, if it's the root, you actually put the root down. Okay. So that's the minus 2. What do we put on the other side of the box? 3, 8, 5, negative 7. Okay, now what? Skip a line, draw a line. Bring down the 3. Negative 6. 2. Negative 4. 1. Negative 2. Negative 9. Okay? All right? Now we don't care what the quotient is. All we care is the remainder here. Let's see. This is saying that f of negative 2 is equal to negative 9. Let's check it and see. Plug in negative 2, what do you get? 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Okay? What's negative 2 cubed? Negative 8. Right? Odd number of minus signs, you keep it negative. Even number, you make it positive. Okay? Plus 8 times 4 negative 10 minus 7. Okay. 3 times negative 8, negative 24, plus 32, minus 17. Okay. What's minus 17 and minus 24? Minus 41, isn't it? Is that right? Minus 41 plus 32. Second. Negative 9. Ding, 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 ding. There we have it. Second. I can't hear you. Say again.
That's just to check it. That's like.
Oh, yeah. I was just showing you, indeed, it works on this one too. So it works on every one of them. Which you think was easier? This or that? Yeah, actually, this is pretty easy. It's just really simple math. It's not hard math, but it's a lot more complicated. Okay? So, now it's a real simple thing to plug in. Let me give you a hint, folks. If you're evaluating x equals 0, you want to do this for Latin? No, x equals 0. All these become 0, you get negative 7. Remember, that's your y-intercept, right? Okay. That's easier to plug in. In fact, even 1 is easier to plug in. Because if x is 1, that's 1, that's 1, that's 1. So you just add your coefficients together. So f of 1 would be 11 plus 5 is 16, minus 7 would be plus 9. So it's much easier to plug those in. But when they get bigger numbers and negative numbers, I think this is easier. Okay? So pay your money, take your choice. Both ways work. Do whichever is easier. Right? Up to you. You've already paid your money. Okay? So let's see how they did it. All right. Using synthetic division, they put the negative 2 on the outside. Now remember, when it's written as in a factor type form, even though it may not be a factor, you put the opposite number. Okay? If you're writing an equal form, you put the number. Okay? So put the negative 2 on the outside, you put the 3, 8, 5, negative 7. Oh, I didn't do this. How many numbers should we have here? 4. 1, 2, 3, 4. Yeah, we got it. Look at that exponent, maximum exponent, you've got to have one more number. Okay. Okay, then we skipped the line, drew a line. They did. Bring down the 3. Negative 2 times 3, negative 6. Add, positive 2. Multiply, negative 4. Add, positive 1. Multiply, negative 2. Add, minus 9. I like to separate that off. There's your solution. There is that polynomial evaluated x equals negative 2 every time. That you can use synthetic division. Not long division, synthetic division. It works every time. That's the remainder theorem. Okay? So, because the remainder is negative 9, you can conclude that f of negative 2 is equal to negative 9. That's what the remainder theorem tells us. All right, that means that negative 2, negative 9 is a point on the graph of f. Okay? So when you're graphing functions, if you just got some scratch paper, just do synthetic division. Plug in, real easy to do. You can check this by substituting negative 2 in the original function. We did it, and they did it, and they got the same thing we did. 3 times negative 8 plus 8 times 4 plus 10 minus 7. Negative 24 plus 32 minus the 10 minus 7 is minus 9. Good for them. Okay. Any questions on that? Okay. So there's the remainder part of the remainder theorem. Now let's do the factor part. Another important theorem is the factor theorem, which is stated below. So if f of x is this polynomial function, and it has a factor x minus k. It's a factor. That is a factor if and only if f of k is equal to 0. Because what's the only thing to show it's a factor? What would indicate that? If your remainder was 0. that minute went into an exact number of times. So that made this thing a factor. So this is basically based on the remainder theorem. Because if indeed this is a factor of that, your remainder will be 0. So if you put alpha k in there, you get 0. So that's one way you tell if you've got a perfect factor. Or a solution, if k is a solution. So using the factor theorem, you can test whether a polynomial has x minus k as a factor by evaluating the polynomial at x equals k. In other words, do your synthetic division. If the result is 0, then you know x minus k is a factor. If it's not a factor, okay? Just that simple. Now, what we're going to do next, not in this section, but the next section, when we're finding the zeros, this is how we find out if there's zeros. Have this big, long, ugly polynomial. Rather than plugging everyone in and seeing if it comes out to be a 0, just do your synthetic division and see if that remainder becomes a 0. If it is, then that's a factor. If it's not, it wasn't a factor. Okay? So, let's do example 6. All right. Show that x minus 2 and x plus 3 are factors of that polynomial. Okay? Then find the remaining factors. How many more might you have? What's the maximum number of factors you could have for this? In other words, let me ask you a question. What's the maximum number of zeros? Not, okay. Zeros would be 4. Remember? That is the end. Turning points was in minus 1. Number of things in the synthetic division, number of numbers in synthetic division is 1 more. That's your 5. Zeros would be 4. Turning points would be 3. Okay? So, we want to show that x minus 2 is a factor of that. How would we do that? Say again? Yes, and how would you do it? What you put on the outside? 2. What you put on the inside? 2, 7, negative 4, negative 27, negative 18. Do you have enough numbers there? Yeah, 5 and the maximum exponent was 4, you do. What you do next? Skip a line, draw a line. Then, bring down the 2, 4. Say again? I can't hear. I can't hear you. Add, right? You add. Oh, I'm sorry. Okay. Yeah, you add. Remember, when you change signs, you add. So you change the sign from a minus to plus, so you're adding now. So that adds to 11, 22. This isn't looking good, is it, folks? What's that? 18, 36, 9, 18, 0. Ding, 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 ding. We have a factor. This shows if that remainder is 0, that shows x minus 2 was a factor. Now, how do we show that x plus 3 is also a factor? Not quite. You can. You certainly could do that. But you know, if x plus 3 is a factor of this one, then x plus 3 will also be a factor of this one. So you don't have to go back to the big one. Start right here. And do what? Minus 3 on the outside. Skip a line, draw a line. Bring down the 2. Negative 6. 5. Negative 15. 3. Negative 9. 0. Ding, 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 ding. We've got another factor. Now, the second part of the problem said, find the remaining factors of that. How can we do that? They didn't give us any hints on that. But what's this down to now? What does that represent? What does it represent? A 3-term polynomial. 0 degree, first degree, second degree. That's a quadratic. Doesn't that represent 2x squared? Continue. Plus 5x plus 3. Hey, maybe we can unfoil that. If we can't unfoil it, maybe we can do AC method. If we can't do AC method, maybe we can do quadratic formula. We got a lot of things we can do once we get it down to 3. Don't try any more synthetic division. This is easy to do this most of the time. What's the only possible factorization for 2x squared? 2x times x. Very good. And then what signs do we have? Second? Plus and plus. Very good. All the possible factorizations of 3. 3 and 1. You want to try that? Try it and see. Okay? 2x times x is 2x squared. That works all right. 2x times 1 is 2x. Plus 3x is 5x. 3 times 1 is 3. Yes, you got it on the first time. There's your last two factors. Fantastic. Okay? That will work really good if they give us the first two factors. We'll find the next two, right? Now we'll find out a way to come up with our own possible factors. All right, unfortunately, it's happened again. Okay? We've run out of time. How sad. Okay? That was example 6. We didn't get to see how they did it. Let me just clear the slides here, just because I know you'll want to go home and check this. So I'll put it up here. They did the synthetic division. They got a 0. Then they used what they had as the quotient. Do synthetic division. We began with minus 3. They came up with 2x squared plus 5x plus 3. Then they factored that, and sure enough, have a complete factorization of f of x. We didn't have the tools to do that before. Now we can factor a big old 4-power polynomial. Okay. Man, that puts us right at the end. What we'll do next time is start with vocabulary. Homework exercises, you know what to do. Do number 7, do number 9, do any of the odds 11 through 23, any of the odds 25 through 43, any of the odds 45 to 49, 51 to 53, or 53, or both, 55 to 61, 63 to 69, 71 to 75, either 77 or 79, and then any of the do 81. Try to do 81. Okay. Now, before you go, let me give you your quiz. We aren't quite through, so this won't be, your clock won't start yet. Okay? Test 1, test 1. Okay. Yeah, where is it? Here it is. Here's quiz 2. All right. Do you need graph paper?
No.
Okay. Do you need graph paper? Okay. Do you need graph paper? Okay. Do you need graph paper? Do you need graph paper? You need graph paper? Okay. You off the bar. Okay. Need graph paper? Okay. Need graph paper? Okay. You off the bottom of the deck here. Okay. Need graph paper? Okay. All right. You graph paper? Okay, you graph paper? Okay. You graph paper? Okay. You graph paper? You graph paper? Okay. You graph paper? All right. We'll see you Monday. Have a good weekend. Working on math. That will make it good. Okay. You graph paper? You graph paper? Okay. All right, everybody got one? Fantastic.